Hello and welcome to our last video of the year. I'm a little bit sad. I've enjoyed sharing my knowledge with you this year and creating some videos. Hopefully you have enjoyed them too. So our last one is going to be on magnetism and electromagnetism, and I suspect that you guys know a lot about magnets already. They have a north and south pole and they attract metal like iron, cobalt, and nickel. And where do they have their strongest attraction? And if you said at the poles, then you are obviously correct. And so a lot of times we want to move metal around, but we can't use permanent magnets. These came out of some speakers. They're used to direct the sound. And if I move them closer together at some point, they attract tremendously, and then it takes a little bit of work to get them apart, right? So remember, work is exerting a force in the same direction that the motion occurs. So I'm pulling out, they're moving out anyway. We can't use permanent magnets to pick up big heavy metal objects like engines because they would stick and then we'd have to pull them off. And so instead we use something called an electromagnet. And an electromagnet is made out of a coil of wire, generally copper, that's wrapped around an iron core, and I used a nail. And then I've sheathed off the insulation from the end so it will conduct electricity. And remember, whenever we send electricity down a wire, it creates a magnetic field around the wire. So there's a magnetic field around each one of these little coils of wire, and that builds up to create an electromagnet. So I'm going to use a 1.5 volt D battery. And if I, oh wait, beforehand, haha, how many does it pick up without the current running through? How many paper clips? Right, 0. So you want to predict how many paper clips it will pick up? All right, let's see. Let's see. And look at that, it picked up 2 paper clips. Move it up. And then if I disconnect it, they fall off. See if I can get a few more. It looks like maybe, can I get 4? Oh, almost. Oh, I got 4. 1 fell. All right, again, got 3 this time, and once I disconnect the electricity, there is no more magnetism because magnetism is only created around a current carrying wire or around a piece of iron, cobalt, or nickel that has all the domains lined up in one direction. And I wanted to show you one more thing, and that's an application of electromagnetism. This is a radio, and it's a special radio in case of you have lost power, you lost cell service, you can still listen to the radio. So I crank the handle, and it creates an electric current, which then runs the radio. I'm sorry it's not an ad. I was really hoping we'd be on a song. So I'm going to turn the volume down because it's still running. And let me explain how that works. So when I turn the crank, I am actually rotating a coil of wire through a magnetic field. And so whenever the wire moves through the magnetic field, it pushes, the magnetism pushes those electrons through the wire, and that creates an electric current. This is how any electricity is generated. You've got some sort of kinetic energy, could be steam rising or water falling, but that energy goes in to turn a turbine. The turbine consists of a magnet and a coil of wire, kind of like your electromagnet, except we have a magnet instead of the iron core, and that movement of the wire through the magnetic field creates an electric current, and that electric current then comes to your house. And one more cute little application of electromagnetism. It's kind of it's my nutty dancer. think I'll leave you with the Nutty Dancer. Have a good summer.